If we discuss layman's term means if even if you will discuss at your home, so they are aware, everybody is aware of this term artificial intelligence, and even if you will ask some kid, even they will be able to speak about artificial intelligence, but how they will be describing it, they will be describing it like a terminator. Okay, so something they must have seen in the movie, they'll be describing it in that way, and then basically they'll be expressing that yes, what exactly is artificial intelligence. But if you will talk in terms of a researcher or somebody who is practicing artificial intelligence, so in that case you'll be able to see that they will have a different explanation. They will explain that it is a set of algorithms that can produce results without having to be explicitly instructed to do so. Okay, so both of them are very much correct at their level. Okay, like even the person who is very naive, who is just a user or an observer of AI or AI products, so they will be able to they'll be thinking it as an end product, and those who are actually working, they'll be speaking in perspective of how the development actually takes place. Now, we had already discussed this, so I'll very quickly run through this. So, artificial intelligence, it is an approach to make computer a robot or a product. So a computer, a robot, and or a product to think how smart human thinks. So this is what is an approach. It is study of how human brain think, learn, and decide to work. So this is important. Like this is fundamental. Like how a human brain thinks, how human brain learns and decides when it tries to solve problems. And here we will understand like what is a problem, and how to formulate a problem, and then how a search, like how basically search is basically how the problem is basically solved. So there basically the search concept comes in, so we will discuss that part as well. Now, and finally, this study outputs intelligent software systems. The aim of AI is to improve computer functions which are related to human knowledge, for example, reasoning, learning, and problem solving. This is something which we had been discussing yesterday as well. Here, in few words, if we say, so here you can see an intelligent entity created by humans, capable of performing tasks intelligently without being explicitly instructed, and capable of thinking and acting rationally and humanly. Okay, so this is what is all artificial intelligence. And now we need to understand what is intelligence, because intelligence is not something which is like physically somewhere it is we are able to appear, like we are able to touch it or we are able to feel it. Intelligence is not like that. Intelligence is intangible. Okay, so in like if I'm able to I have a water bottle, I can pick it up, I can have water from it. So intelligence is not like this. So intelligence is reasoning, intelligence is learning, intelligence is problem solving, perceiving. It can be linguistic intelligence. So intelligence is different from what is we are able to see as a physical world. Okay, so those physical world entities, they are different objects, but it is different from it. It is intangible, it is not, we are not able to touch it, and these are certain areas where intelligence can be applied. So this is primary thing we need to understand, because if I want to make the machine or a program intelligent enough, then I need to basically think of on this level. So let's do some mock-ups here. I have yes, let me just create some uh, a Python notebook. Okay, and let's create some programs. So if you are in programming background, so don't like I'm not going to do any very complex programming now. Just for demonstration purpose, let's start. Okay, so gradually I'll try to take you through different levels of like how we can have scenarios created for AI solve problems as well. So let's say if this is my Jupyter notebook. So let's say I want to create a smart system. Okay. And we were talking about vacuum cleaner only yesterday. Okay. So let's have something related to that. Let me make it little larger. Okay. So that it is visible to all. Yes. So if I'm talking about vacuum cleaner only, so I'm just creating a simple program here for vacuum cleaner. So this is a program for vacuum cleaner, and I'm giving it. I'm setting some parameters here. Let's say what I want is, okay. So here, I want this. There will be some input. Okay, so there will be some input, and it should be able to take that input. So as of now, okay, in a device, the input could be a sensor. Okay, or it could be a camera in a device. Okay, but in our case, everything will be some input. Okay, as of now, we will have everything as keyboard inputs only. Okay, so then after the input is taken, what next is required? So next thing is, so this part is that like our program should be able to perceive, okay, perceive the input. And after perceiving the input, the program should have some logic. Okay, so we can say it as, let me write it as logic only here. And yeah, logic only here, and let me write here as, so that logic is basically its knowledge. Okay, so program should have its own knowledge, and that is something, the logic we will provide. So here we will write certain conditions. Okay, conditions. Okay, with we will give we will give some conditions mapped with outputs. Okay, so under which condition what output needs to be run. So that is something we are going to uh, provide. So this is one thing, and then last thing, as of now, I can simply have is the output part. Okay, or we can say the action part. So action is the output part. Okay, and this is basically done. Again, I can write it as actions only. Okay, and in physical devices, this output will be performed by some actuators. Okay, so actuators again can be maybe some motors. Okay, or maybe some, um, in this case, some suction pump. Okay, so I just forgot the, okay, let me just write pump. I don't know the spelling. Okay, so yes, so some physical entity would be there, and that would be performing the actions. Okay, so if I want to demonstrate this, then I can simply start by let's say I can do create a class, and I can do all these things. So let me just create a class, and it's VACC vacuum CLEANER. So vacuum cleaner. I created a class, and I can create here. Let's say it has got us some. Uh, I can write it as perceptrons. Okay, perceptrons. Okay, to perceive or to take input. Okay, so to take some input or to perceive, I will create some perceptrons here. Okay, so the perceptron could be, I can take as a sensor. Okay, so sensor is there. So sensor is going to take some input. Okay, so I will name it as sensor input only, so that if I write sensor, then it becomes sensor, but I'm writing it as sensor input, so that whatever input is coming, that input can be kept into sensor input. Or else I can do one thing, I can take one as sensor. Okay, and it could be, let's say, whatever I'm just writing here, x m and 1 2 3, some model number of the sensor. I'm giving a default value. Sensor input as of now, let's say initially, let's say this is kind of boolean data type. I'll write, okay, true and false. Okay, so here I'll write and comment also. So true, let's say, means true means clean, and false means false. I'm taking it as, let's say we can take it as uh, dust. Okay, it's not or dirty. So if it is true, that means it is clean. So until and unless it is true, like till the point sensor input is true, we have no problem. Like everything is fine, and like the vacuum cleaner need not to do anything. Now here, so I have taken only two things. Okay, and third thing I will take as uh, one let's say one pump, and so it's again this will have some again I'm giving some xx p123, so, okay, because everything will come into the functionality part. So these are some this is actuator, okay, this is the action performing element inside the vacuum cleaner. So this is the actuator. Okay, the pump is the actuator now here. Now I will create the like how these actuators will actually work, how the sensor will work. So I will create two functions over here. Okay, so I'll create two functions. One function is basically um, yes. So one function I'll write def and sense sense input. Okay, I'm writing sense input, and in sense input I will be taking a parameter as yes, sensor input is already there, so I need not to take any parameter. So I can just check here. So if I can check self dot sensor input, so sensor input, okay, yeah. So yeah, so here you can see if it is equal to false. Okay, so if it is equal to false, then what to do? I'll have to write here something. Okay, else what to do? Okay, I'm just writing pass as of now. Okay, so this much is my function. Okay, one function, and what I will do, I'll write one more function def, and I'll write clean function clean. Okay, and here again self, and yes. So here I'll just print a message as of now, because we are not going to do anything real, so it is just a dummy. So print uh, the surface is cleaned successfully. Okay, the surface is cleaned successfully. This is what this function is going to tell us. Okay, because it is going to clean. So here what I will do in this case, if self dot sensor input is equal to false, if it is false, in that case I will just call self dot clean. Okay, so because if I'm going to call clean, it is going to clean it. If the sensor input is true, that means the area is already clean, then we need not to call this function. So you can see that this is the logic part, or I can write here itself. Okay, here. So this is the logic, or you can say the knowledge we have given. Okay, very simple simulation. The knowledge we have given. Okay, with the help of this knowledge, the our system will be able to work. Okay, now this is complete. Okay, this code is complete. A small piece of code I have completed here. Now let us do one more thing. Now we will just write a small program where we will create an object of this vacuum cleaner. Okay, and that object will be functioning as per the sensor. Okay, as per the input entity, as per the actuator, the one who will be performing action. Okay, and as per their functionalities, this particular program is going to work. So let's have the further program here. What we can do, we can create one object of this vacuum cleaner. Okay, so let's say we have vc1. Okay, so vc1 is the object of this vacuum cleaner. So let me just write let's create an object of the vacuum cleaner. Okay, creating an object of the vacuum cleaner here. So I am giving it name as vc1. So vc1 is the name of the vacuum cleaner, and I'm just writing vaccum vacuum cleaner. Okay, so this will help me to create the object. Okay, so the object is created. Okay, now if I want to call upon instead of else, what I will do, I can write here the surface is already cleaned. Okay, so I can just print here instead of writing pass. Here I will print the surface is already cleaned. Okay, so the surface is already cleaned. Here we have written already cleaned, and here we can write cleaning cleaning dot 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 slash n. the surface is cleaned successfully. Okay, okay. And here we can write agent cleaning the surface. Okay, yes. So now let me execute it again. So I have created VC1. Now let us check. Okay, so here I will use the function VC1 dot sense input. So it is trying to sense the input. Okay, and execute it. So it says the surface is already cleaned. So now in this particular case, so here we created a simple logic, and in this simple logic, we have created one class vacuum cleaner, and this is basically like a prototype. And with the help of this class, we created actual object VC1. And when we are trying to use the function sense input, so think it like we are pressing the button. Okay, like we are just pressing the button, like switch it on, and after switching it on, whatever is happening, that we are able to see here. Okay, so we switched the button on, okay, for sensing the input, and at that time it was able to sense the input, and it was able to check whether the surface is dirty or not, and it told surface is already cleaned. Okay, now I will add one more logic here. Okay, I will add one more logic here. So yes, so here I'll add input. Let me just yeah, so I will just do self dot sensor input is equal to input, and I'll take an input from the environment. Okay, so as of now we will have to give the input because we are mocking this program. So here I'll ask uh, okay, sensor sensor is uh, wait VC, so vacuum cleaner is observing observing the environment. So the vacuum cleaner is observing the environment. Now, while observing, we will have to provide it with true or false. Okay, so true means clean, false means dirty. Okay, so here, as of now, as I said, because we will have to act like the environment as of now, so we'll have to provide this input. So now I'm again creating this object, again calling. So it is asking, okay, so VC is observing the environment. True means clean, false means dirty. So it was by default true. So I'm just putting here FALSE, false, enter. So now here you can see the surface is already cleaned. Just a second, what I did, I have put false, and okay, fine, I got it. Yeah, so I should have taken this as a string. I have not taken this as string. Yeah, let me take it as string, and now let me do it once again. So FALSE, false. The surface is already cleaned. Okay, it is not accepting it. Okay, let me just self dot uh, sense input. Okay, I'm sorry. Yeah, so here I have written wrong. So sensor input, so it was sensor input I should have written. And let me just remove this as of now. So let me just see if it is taking boolean or not. Yeah, so once again I'm executing this. Okay, so yeah, let me put FALSE, false. Yeah, so it is taking surface is already cleaned, and this. Not taking that way. No worries, control Z. Okay, let's make it simple. So here, sensor input, we have taken, let me take it as empty string. And yeah, so it is taking here, and if it is FALSE, false. Okay, so then self dot clean needs to be called, and okay, yes. Yeah, now it is perfect. So just data types I tweaked. Okay, so I have taken now it as a string itself. So here you can see that now we can pass the input. Okay, so if it is true, in that case it is already cleaned. If it is false, that means the agent needs to clean it. So here you can see agent cleaning the surface, and the surface is successfully cleaned. So what is happening here? So we have created a simple logic here, and with the help of this simple logic, if the surface is already cleaned, in that case it will give the output as the surface is already cleaned, and if the surface is not cleaned, then the agent will start cleaning it, and then it will tell that the surface is cleaned successfully. Okay, so this is how it is going to perform. So going back here, yes, so what we were discussing, that uh, in in real time we have a problem. Okay, and we are trying to solve that problem with the help of a logic where human intervention is not required. Okay, where human intervention is not required. So that is something we try to build with a simple Python code. Okay, any programming you can use, and this logic, if you are able to perform, so we can say that yes, it has got little intelligence. Okay, now, yeah, moving ahead. Now, how do we measure if the artificial intelligence is acting like a human? So for this measurement, there were certain tests. Okay, so here you can see Turing test, the cognitive modeling approach, then the law of thought approach, the rational agent approach. So there are multiple approaches to understand whether a machine is intelligently acting or not. Now going back to this small program. Okay, I'm going back here. So now looking at this program. So if a vacuum cleaner is able to sense and is able to decide that whether the surface is clean or not, and accordingly if it can act, so will you put that particular vacuum cleaner device as an intelligent device? I would require quick responses in the chat. So would you put, or would you classify it as intelligent? Yes or no? Or would you say that it is not intelligent? So what will be your call on that part? Yeah, quick responses on the chat. Yes, for if you will classify it as yes, it is intelligent. Okay, so here we have one response as no. Okay, yeah, I'm expecting at least 2 3 more responses. So the first response is no. I would also like to request, if possible, still need more. Still need more. Okay. 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 Yes. So I'm getting responses here as no. Yes. So let's get back to the primary definition of yes. Let's get back to the primary definition of uh, artificial intelligence. So it says that if a machine is able to, okay, okay, let me accept here. Yeah. So I've got one yes. Okay. At least I'm getting one positive response for this. So we will discuss it little later. Okay. We'll discuss it little later. Okay. Now here we have. Some approaches. Let us discuss these approaches, and then we'll come to this part back again. Yeah, so here we have a Turing test, a cognitive modeling approach, law of thought approach, rational agent approach. Let's discuss these approaches. Okay, what are these approaches which are helping us to measure, uh, understand how do we measure if artificial intelligence is acting like human? So there can be a degree. Okay, there can be a degree. Let's say if I develop some scoring system, and the scoring system is beginning from 0 and ending at 10, so there will be a score. Okay, there will be a score given to a particular machine. Okay, so therefore similar way this program can be given some score. Okay, this can be given some score. Okay, so now we will give that score later. Turing test. This is very famous test. Everybody is aware of this test, and those who have read anything about artificial intelligence. So in this, what actually happens? Okay, let me just run one simple program. If I have it here, let me just see if I have that here. So last modified 2 days, 2 days, smart reinforcement, restaurant review analysis. Do we have that? Let me just check. No, this is a different one. Okay, so it's fine. Yeah. Yeah, so what exactly this particular Turing test means? Okay, this is basically a test which where a human is there and there is another. It may be a human, it may be a machine. Okay, so now a human is trying to interact with a machine. Okay, and the human doesn't know that on the other side there is some machine interacting with him. So if they keep on chatting, if they keep on interacting at any point of time, if the person is able to recognize that on the other side it is not a human, rather it is some chatbot which is interacting with me, in that case the test fails. Okay, but if the human is able to identify that on the other side is not able to identify that on the other side there is a machine, then basically in that case we say that the machine is intelligent. Okay, so the basis of Turing test is that artificial intelligence entity should be able to hold a conversation with the human agent, and the human agent ideally should not be able to conclude that they are talking to artificial intelligence. Okay, so this is the primary parameter, that human should not be able to identify that he or she is talking to some artificially intelligent device. Now here what sort of skill sets are required? The machine should have NLP, okay, natural language processing, so that it can communicate, it can understand and process the human language and then respond back in human language back again. Then second is knowledge representation. This knowledge representation is again very important part, that how if the machine is able to understand what language is being given as input to the machine, but it is not able to represent it back as an output, then in that case again that part is lacking. Okay, it would not be able to converse with human. Okay, so knowledge representation is another important part with the machine. Then automated reasoning. So automated reasoning is, let's say there are certain, so this scenario also we can create. Okay, a small scenario we can create here. So we have, let's say, a small kid is learning from experiences, and while learning from experiences, the kid stores all the experiences in the memory. Okay, as some sort of input and output maps. Okay, so this will happen, then this will be the output, this will happen, this will be the output. So similar way we'll have to create that kind of mapping, and then the system should be able to read those mapping and try to find out the answers. Okay, so here it could be as simple as there is an input and an output, so which we call it as reflex action. Yesterday I was explaining that as soon as we touch a hot plate, the hand automatically goes at the back side. That is the kind of reflex action. There is no thinking required over there. It's just a reflex action. Okay, so that is one thing. But if there are complex situations, for example, if you are getting a new offer and you have two offers in hand, and now you need to decide. Okay, you need to decide now that. Which offer you need to take up. So here it won't be a reflex action, you can understand. Here you will think, you will try to analyze that which is the better opportunity, which is nearer to house, which is having higher package, what kind of job profile I'm getting. So all these things you will get into your mind, and will be the parameters to decide that which job opportunity should you take up, or should you continue with the current job. Okay, so there will be reasoning. So this kind of reasoning should be there in the machine as well, the program as well. And the last and important part is machine learning, because the above things are very much possible with the help of machine learning. Okay, so machine learning is basically trying to identify the patterns, and based upon the patterns. Okay, because if we are getting newer and newer data, so the over the period of time the patterns would also change. So machine learning algorithms will help us to adapt to the new patterns, and we will be able to we will be the machine will be able to adapt to new environments or new circumstances. So this is one approach, that is Turing test, and it requires NLP, it requires knowledge representation, automated reasoning, and machine learning. Now let us move ahead to second approach. Okay, So this approach, how to implement this again, just to mock it up. So how can we do this? So we can have it something like a set of rules we can create. Okay, or yes. So here, let me just write it in comment. Let me just mark it down. Yes. Okay. So if you want to go for Turing test approach, okay, so what it is trying to do is it is working with an NLP. Okay, so that means there are certain um, uh, I can say it. Let me write it as NLP only, because otherwise it'll get into a lot of keywords. So it should have NLP. It should have then a way of knowledge representation, and it should have then reasoning ability, and then it should have the last one was machine learning. Okay, machine learning. So Turing test is under this. Okay, uh, I will create a program together for multiple. Okay, then we'll demonstrate that part. Next part, let's understand in cognitive modeling what is happening. So cognitive, if you go with the word, so it is basically how the neural activities, or how the activities inside human brain actually they work. It is related to that. So in this approach, if you see, again we have three subcategories. Okay, one is introspection, second is psychological experiments, and third one is brain imaging. Okay, so introspection is basically observing our thoughts and building a model based on that. Okay, so observing our thoughts. Okay, again let me create it here in some way. So for example, there is a scenario which I just explained, that if whether to take up a job or not. Okay, so if we have to make a decision on this part, whether to take up a job or not. So for that, let's say we have certain parameters, and based upon the values of those parameters, we will decide whether to take a job or not. So I'll just create a list. Okay, so let's say we have parameters. I'm creating a list as okay, an empty list here, and then I'm taking input all the parameters. So yes, what I can do is hmm, so I can do it like this only, input. Okay, yes, enter. Okay, okay, I'll just ask. Hmm. So what is the most important factor to change job? Okay, so if this is a question, what is the most important factor to change a job? Okay, so let me take this into a loop. Okay, so that we can have multiple entries. Okay, so I have created it as an entry empty list. So for, let's say, I in range. So parameters dot append, and yes, whatever input will be given. Fine. Yes. So here we are taking from 10 people, what is the most important factor for a job change. Okay, so let's say somebody will say salary, somebody will say job position. Okay, whatever position we are getting. Again, somebody says salary, somebody may say, let's say, designation, then location, then company, somebody says organization, and let's say again somebody says salary, and designation, and organization. Okay, so we have got certain inputs from 10 people. Okay, and these take them as the thought processes what people are having. Okay, to decide like the most important parameter to make a switch. Okay, So in this, the first part, it says that observing our thoughts and building a model based on that. So what we did, that here we are observing thought, okay, from 10 people we did it, okay. So one said salary, job position, okay, this way. And now if we are able to identify that how to decide, okay, so if I want to decide on the basis of top two parameters, so I can just have a count of salary, I can just have a count of job position, I can just have a count of again each of the thoughts present here. Okay, when I'm getting a count of them, so mostly here I can see I'll be getting salaries as the 3 count, I'll be getting designation as 2, I'll be getting organization as 2. So what is happening, like 3 times salary was the primary factor, 2 times designation was the factor, and 2 times the organization was the factor. And if I go into NLP, then company and organization are same thing. So salary 3 times, organization 3 times, and designation and job position are again same thing, so designation 3 times. Okay, so location is not much important in this case, so most of the times these 3 parameters are basically helping us out. So this is basically a kind of demonstration for introspection, like observing human thoughts and building model based on that. Okay, so what is important, this observation is your initial data, the food for creating the model. Okay, so this observation is required. Second is psychological experiments. In this, yes, so conducting experiments on human and observing their behavior. So here basically if you see, it is observing the thoughts, and in psychological experiments again there is a mapping. Okay, mapping is conducting experiments and then observing the behavior. So we did some experiment. So here in the second case we offered higher salary, and we tried to understand whether the person took that opportunity or not. We offered a better job position, then we tried to understand whether people are taking it or not. Okay, so by doing an experiment and then basically mapping it with the output, that job position is high, the job accepted, yes or no, the salary is high, yes or no, salary is low, yes or no. Okay, so this is another part, which is psychological experiments. Then third part here is brain imaging. So this brain imaging is we all are aware, MRI. Okay, so here recently I had seen one video by Neuralinks. Okay, so Neuralinks is a company, and they released a video, and that video was that there is an ape, a monkey-like creature. So he was given a game to play with the help of the joysticks, and he was trying to play that game with the help of joysticks. But after some days, what they actually did, they captured all of the MRI scans, that how the brain activity is happening for that particular creature, okay, that monkey. And what they were able to observe, that whenever he was making a move or making some changes, that time the pattern was clearly visible, it was a similar kind of pattern. And now they programmed the game, that whenever the brain activity, the MRI scan data is having this pattern, then perform this action. If the input is little different, then perform different action. And they actually removed the plug of the joystick, and they allowed that monkey to play without the joystick, and he was able to play without the joysticks, just on the basis of the MRI scan data. Okay, so this is called as brain imaging, where basically the MRI data can be utilized to identify patterns of basically human behavior. Okay, so what time human behavior changes, when the human is excited, or when sad, or okay, so whatever moods or swings are there, all those are basically having some sort of pattern in MRI. Okay, so these three are approaches in cognitive modeling. Next approach is the laws of thought approach. So here this is again a mapping. Okay, if you see the first one, the Turing test, it requires NLP, knowledge representation. This is a different approach. If you require this is again observing the thoughts. Okay, so this laws of thought is little similar to the introspection part and psychological experiments, but let us understand what exactly it does. So here we can have every human thinks differently, but still for solving a standard problem, we may have two ways, three ways, or a number of ways to solve a particular problem. Okay, so what we can do here in case of laws of thought approach, uh, here we can have all the list of logical statements that basically help our mind to make a decision. Okay, so all those logical statements we can list them down, and now this list can be codified and applied to artificial intelligence algorithms. So what is happening? So in the laws of thought, okay, so here we have a list of thoughts, or we can say list of logics. Okay, with input and output. Okay, so with input and output, we have whole list of logics, and this logic, this list is given as input to the algorithms. So the algorithm is going to learn from these list of logics. Okay, yeah, so that is the approach here in case of laws of thoughts. Now here the challenge is that in many situations there are many multiple situations where we are not actually working as per the list of logics. Okay, if we have a logic, but because we are emotional too, human beings are emotional too, so many a times we don't work as per the logic. So there basically this laws of thought will be lacking to give the kind of real solution mind actually produces. Okay, so that is a challenge. So the issues with this approach is because being a problem solving principle strictly according to the laws of thought, and solving them in practice can be different. Okay, because we understand the context, and then we actually do certain things. For example, let's say if somebody did commit a mistake, so as per the law that person should be punished, but we will try to understand the whole context, and then we will see that whether punishment should be given or not. So there is a difference. Okay, this basically becomes a major difference in practical solutions and what this particular approach can do. Okay, and the last approach is rational agent approach. So this is basically, you can say, advanced version of laws of thought and better version of it. Now, because there are certain situations where we don't apply the logic, or we can say we apply the logic, but sometimes logics lose their meaning. As I said just now, if somebody committed a mistake, okay, then as per the logic the person should get punished, but sometimes the situation was so that the logic should not be applied. So in that case, basically, we can go for rational agent approach, where it will not have only one set of rules and giving certain output, but it will have more than one set of rules which will understand the whole scenario, and then they will give the best possible outputs. Okay, so rational agent approach, it is again an advancement to the laws of thought approach, but it is going to work in a better way, because it is not only going to just work as a rule that this is the rule and we have to follow this. It is not going to work that way. It is going to add certain more circumstances and understand, and then it is going to deliver some output. Okay, so these were certain approaches that we have. Okay, now, after this, yes, how artificial intelligence actually works. So here we have certain things like machine learning, deep learning, neural networks, NLP, computer vision, cognitive computing. So we had discussed certain things yesterday, so we will not get in depth of it. So ML we had discussed that it is, let me just put it here in short. Yes. Yes. So the first part written there is ML and machine learning. Let me put it here in short. Yesterday we had discussed that like if we impart logic to a machine, that is AI, but logic should be evolved over the time and machine should be able to learn over the time. That is the most important part. So any application you see, that application is an AI plus machine learning plus deep learning plus NLP. Okay, so that machine is like this. So now here if I talk about ML, so in ML we will try to understand it like, okay, yeah. So ML, let me just take something like X and Y. Okay, so we have something called as X and something called as Y. Here X is your input, okay, and Y is your output. Now, machine learning completely works upon, let me take it here. Machine learning completely works upon input, which are nothing but experiences. And these experiences, yes, so these experiences are nothing but past data. Okay, so it works on experiences, which is past data. And output is basically labels or basically observations, again, of the X. So output is whenever some X condition was there, and at that particular time, what was the output? So this is a combination of X and Y. So in machine learning, you will have either both X and Y, or in some cases you will have only X. Okay, in machine learning, in both the cases you need to formulate an algorithm, which, so here you need to formulate an algorithm which we call as model. Okay, so model is your algorithm. You need to formulate an algorithm, and this algorithm is to find a formula. Okay, so to find a formula to map X and Y. Okay, so this algorithm's objective is to find a formula to map X and Y. Okay, let me take it like this. Okay, to map X and Y. But if you have only X available, in that case, to group X on the basis of similarity, or you can say differences. So if you see here, majorly two approaches. And the third approach. So here, let me write, when X and Y are present. Okay. And in the second case, in this case, when X and Y are not present. When X is present and Y is not present. Now, another approach is when X and Y are not present. Both of them are not present. Yeah. So those who have gone through ML, can I have a quick response on this part? Like when X and Y both are not present. So what is that part called as? What sort of learning is that? Yeah. What sort of learning is that? Yeah. Can I have quick responses in the chat? What sort of learning is that? Yeah, any guesses? So, okay, okay, I have one. Okay, unsupervised, unsupervised. Okay, okay, yeah, reinforcement. Correct, correct. Yes, yeah. So it is actually reinforcement, the last one. So this first one, first approach, it is coming under supervised. This second approach, it is coming under unsupervised, and this third approach, this is coming under reinforcement. Coming under reinforcement. So when x and y both are not present, so in that case what happens? In that case, it learns from scratch. It creates, okay, so there is a learning which completely happens on the basis of all the fresh experiences. Okay, so here it doesn't create a formula to map x and y. It doesn't create some formula to group x on the basis of similarity or differences, but rather it basically creates memory, the experiences. It's a memory with the experiences, or I can write the fresh experiences. It creates a memory with the fresh experiences, and uses, okay, and utilizes it for reaching its goal. Okay, so Google Maps are best example for this. So if you go to a very new place, very new place, let's say Google has not yet identified that place. So if you go to such a place, then everything is new for Google Maps. But as soon as you are traveling through any road or any way, that is being captured, and that is the part which I have told, creating a memory with the help of experiences. Okay, so that new track, new way is the experiences, and the Google Map application will create a memory. It will keep that way in the memory, and then next time if somebody is passing the same way, it will show the previous traveler's way that this is the suggested way from where you can go, because it has put it into the memory. And then it also asks after that, did you reach your destination, and some sort of questions it asks, and then we say yes, no, we give a rating over there. Okay, and that is a kind of reward, or basically that is a kind of a message it gets, that whether it is able to whether it was able to perform well or not. And if it gets input as let's say from 0 to 5, if we are giving them 5, and if we are giving that yes, we were reached on time, then basically it keeps again it in the memory. Okay, not memory, let me just add here, so it keeps a reward table as well. Okay, so reward table or penalty table, whatever you can call it as. So with the memory, it keeps a reward table, that whenever it performed some action, was it rewarded, or was there a penalty over there, and based on that also it is able to work better next time. So here three approaches we are seeing: supervised, unsupervised, and reinforcement. Three approaches, okay, which are coming under artificial intelligence. Okay, let me cover the other as well. Okay, let me cover the other as well. Now in this case, in the supervised only, this deep learning and neural network, so they share the same domain, deep learning and neural network. So deep learning actually is creating artificial neural network. So this is a different approach. Okay, this is a little different approach, that how this works. So we have seen supervised, unsupervised. Let me give you a little detail on it, and let me give you a detail on the deep learning part as well. Okay, so now in case of supervised learning, let me open up one Excel sheet here, so that it becomes easy for us to understand. So here, is it taking time? Okay. Just give me a second. Okay, yeah. Yes. So here, okay, just have a look at it, like how does it happen? So here I have X. It is still loading. Okay, let me just wait for one more second. No worries. By that time, let me go to this place. Okay. Okay. Yes. So then next we have here as deep learning. Okay, and I'm writing NN as well here only. Artificial neural networks. So in case of artificial neural networks, we have something called as neuron, and this neuron, if we talk about in biological sense, this neuron is a cell, and it has got, it is like we have sensors. Okay, it is like that only. So it perceives. Okay, and after perceiving, it has got a capability to transmit the messages to hundreds and thousands of other neurons. Okay, so you can see that hundreds and thousands of other neurons. If you see the history of deep learning and these neural networks, so frankly speaking, we don't know that how exactly. We know that the neural cells, they are able to transmit and transfer the message they have received, but we don't know exactly how do they make decisions. So there was a worker who was working into this thing, telephone directories, and so there basically lot of wire connections he was able to see, and from there this idea was evolved that if we plug in wires, if we plug in and plug out certain wires, okay, then how does that function? So some inspiration from there it was taken. So I'll tell you that if my Excel is working. Okay, yes, it is working. Yeah, so let me tell you very clearly here. Now, how this learning part is going to happen: supervised, reinforcement, and unsupervised. Okay, three ways, three special model in under machine learning. So we have X and we have Y here, and if you see, let's take example of very simple example: speed and distance. Okay, or let's say we can have it as, okay, yeah, distance only, written distance here, distance and time. Let's have distance and time, and here we will get speed. So if you know that speed is equal to distance divided by time, so this is the formula for speed. So whenever whatever distance you have, accordingly you will have your speed. Okay, whatever time you have completed. So let me just put it some random number. Okay, so ran between. Let me utilize this, and let me put distance from uh, 10 kilometers to 50 kilometers. Okay, and here time, let me put is equal to rand between. Okay, so let me put it between, let's say, 2 hours to 7 hours. Okay, so this is the timing, and yes, so this is the data we have. Okay, so here you can see that I have input, this is X, so this is X, fine, but in input also I have X1 and I have x2, and then in output this is y. So yes, I have x1 and x2 and y, these three things. Okay, so I'm just highlighting this input with a different color so that you are able to easily recognize it. So these are input and these are outputs. Okay, so input and output. So we can in general way the standard term is x1 x2. So x could be there could be n number of x1 x2 x3, which actually determine the output. Okay, now we need we need first approach, that is supervised approach. So in case of supervised approach, what do we actually require? We require to formulate a solution here, not a solution, formulate an algorithm's model. Okay, we need to formulate a model which should be able to always calculate the value of y. So we call this as we need to find a function of x which is going to give us y. This is what we need to identify a function of x which is going to give us a value of y. And here now we know the function that the function is y is equal to, so in our case the function is, here let me write, okay, y is equal to, we know that x2 divided by x1. This is the function in our case. Okay, but in real time situations, this is simple formula, we know this, but in real time situations it may not be like this, because this function is mathematically and theoretically correct, but in real time it may happen that the road conditions were not good, and there was traffic, and there were certain more parameters. Okay, so let me add those things here. I believe you are able to follow me. So here in supervised approach, what is happening? We have x, we have x2 and x1, and we have y. So these two are input, and this is output. So input and output both are present. And now in reality, okay, so this is let's say theoretical output. Okay, this is theoretical output. Theoretical output. Okay. But let me put something here. Okay, so let me just create a scenario for you. So I'm just inserting two columns on the right hand side. Okay, yes. So here road conditions I'm putting, and I'm also putting traffic. Okay, so let's say road condition, let us assume that this is x3, and x3 means 0 poorest and 3 best. Okay, or this is x3. Now x4 is, just give me a second. So here x4 is your traffic, and in case of your traffic, what you can do here again, 0 means no traffic, and then we have 1, which means mild, and 2 means high. Okay, so yeah, so this will range from 0 to 3, this will range from 0 to 2. Okay, and let me put it randomly only. Let me put it randomly. Okay, so is equal to rand between, and the low is 0 and the high is 3. So this is going to be like this. Okay, and let me just stretch it out. Okay, yes, and this one also. So let me take it, yes, like this. So here we have 0 to maximum is 2. Okay, like this, and yes, fine. So now B5 and C5, B5 C5. Okay, fine. Yes. So this is
Excuse me, question, sir. Can you
theoretical
increase the
because
size?
yes, yes, sure.
Actually, it's not visible perfectly. Thank you.
Just a second. So is it visible now? Is it visible?
Yes, yes, yes.
Okay, okay.
Thank you.
Yeah, okay, pleasure. So here, if we see, this is theoretical, but if I want actual, so I'm just adding two more real time parameters, and I'm just trying to represent them in the form of numbers. So the real, okay, now what supervised needs to do, here we will have some real values. I'm first generating that particular, okay, so I'll not show you. I can show you, no worries, because if we know that is something we need to generate. Okay, so let me do here. Yes, so now the speed here is, let's say, it is being affected by obviously this divide by this is the speed, and let me put this into, yes, but it is also affected by the road conditions and traffic. So let me do something like plus, and I'm giving a weightage. The weightage I'm giving, uh, let's say I'll put some value here. Here I'll put some value. Okay, so this, mm, okay, let me do it like this. So this into the road condition, and I'm giving one more weightage plus, so I'm giving this value as one more weightage, multiply the traffic, enter. So suggest autofill, yes. So now I have given here a5, so a5 here, so this I will give as the weight is 0.5 50%, and here I have given a7, so a7 I'll give 0. Let's say road condition 0.6. Okay, so w of road condition, this is w of road condition, and this is simply weight of traffic. Yes, so what I have done here, why it is d5, yeah, so it needs to be that only. Okay, just a second. So let me put dollar $a7 and let me put dollar $a5. Okay. Okay, fine. Still a9. It's getting a9. Okay, let me just make it correct. Okay, let me just put hard-coded value here. So I'm facing issues here. So let me put it 0.5, and I just wanted to make it dynamic. Let me put it 0.6. Okay, now it's all good. So yes, I have put hard-coded values there. Okay, and let me just delete this. Okay, so now here we can see this is the actual y. Actual y. Okay, that is actual speed. Uh, yeah, so it should be less actually, so I should just okay, fine, and otherwise let me, so time this much distance, this much time, and speed, yes, correct. So you can see that if somebody is traveling a distance of 24 kilometers and it is just taking 2 hours of time, then obviously the speed should be 24 by 2, that is 12 kilometers per hour. Okay, but actually the actual speed was 10.9. Why the actual speed was 10.9? Because of the road conditions and traffic, the person had to stop at certain places. Okay, although that person was running at a speed of 24 kilometers per hour. Okay, but he had to stop at certain places, he had to slow down at certain places, and therefore the actual speed was 10.9. Okay, so the theoretical formula will not match here, and this is something we see every day. So here the approach of supervised algorithm is that to identify a formula, okay, that is y is equal to f of x, which can help us with this value, which should help us with some values which are very near to the output which we are actually getting. Okay, so now I will try to, so this is one formula. Okay, y is equal to x2 divided by x1 is one formula. Okay, which already we have applied here, but this formula is not yielding us any result. Okay, so what we can do, I'm just applying a random approach. Okay, I'm not applying any. Okay, what we can do like this. Here I'm putting one formula, y is equal to, so we are seeing here that normally what is happening, so here also, okay, so here only I have done minus, I should do minus at each place. Yes, okay. So what we are able to observe that the speed, the actual theoretical speed is 8.25, but here we can see the actual speed is coming to be 7.65, which is little less. So we will calculate x2 divided by x1, but we will try to introduce some sort of variable. As of now I'll call it as bias. Okay, so we will minus that bias value from here. Okay, so that bias value I need to identify now. Okay, that bias value I need to identify. So that bias could be anything. So this is something I created, and here also the same formula I'm creating is equal to, and I'm creating the formula as in bracket this divide by distance divide by time, and minus I am doing some bias, and now I need to calculate the bias. So I'm calculating the bias, like let's say the bias value can, there could be some I need to have a formula for creating the bias value. So I'm keeping the bias value as static value in the initial point, 0.5, and enter. So if I did this, okay, yes, autofill. So when I'm doing this, okay, some bias value I'm putting, then I'm able to see, I'll be calculating here. I'll be calculating here that this is actual. Okay, this is actual, and one is basically predicted one. So I'll be representing the predicted one as yellow. Let me mark it in yellow color. Okay, and let me mark this in orange color. Okay, so actual will be this. Okay, now this is predicted. Let me write here. Okay, now what will happen here in this case? I need to calculate here what is the difference between actual and the predicted one. Okay, what is the difference between actual and the yes, actual and the predicted one. So that I can do by, so the difference, this is called as, we can call it as the error. Okay, what is the error? We can call it as y p minus y. Okay, so the predicted minus actual, so is equal to this predicted minus actual, whatever is the difference that will be giving us, yes, so that will be giving us basically by how much difference are we differentiating from the actual. So here we can see that the model which we have created, it is having comparatively very less difference from the output. Okay, very less difference, but still it is having, okay, it is having some difference from the actual output. So we need to make improvement in this bias term. Okay, so another thing what I can do is I can involve some weight and bias. Okay, I can include some weights and bias. So I'm creating another formula here. Okay, so this thing will get repeated now. Okay, another formula I'm creating here. The other formula is here, along with the bias, I will try to have some weights also. Okay, so weights could be, let's say some weights are, okay, yeah. So yes, so the weights, I'll put some weights here. So this is D5 E5. Okay, D5 E5. It should be B5 C5. Yeah, let me correct the formula here. So is equal to distance upon, yeah, distance by time. Okay, and now we will include some weights also. Let's say I'm including a weight as 0.4 into uh, this plus this. Okay, so something like this I'm doing, and the bias term I'm keeping it as it is 0.5 and enter. Okay, so this is what I'm trying to calculate. So something I did here, yeah, here I need to put multiply. Okay, and I need to put brackets outside. But I'm doing it manually here, but this is something algorithm needs to do. Okay, I'll explain that as well. Yeah, till this point. Okay, so now if you see, in this particular case, okay, what I did, I introduced weights and bias both. Okay, so plus bias, and we have here minus, I have done weights into, I have done the road condition plus the traffic. Okay, this is what I tried to do. And now here in this one I will again try to calculate the error. So the error here would be, again, the error would be your YP predicted minus Y, that will be error. So is equal to, this is your YP and minus this is your actual Y, enter, and yes. So now here you can see the magnitude. Okay, let me just find the summation of the errors. So summation of the errors in this case, if you see, it is coming as 12.6, and summation of the error, I should take absolute values actually. So summation of the error here, it is coming as minus 3.4. Okay, so if you see, okay, I have not taken absolute values. Actually I should take absolute values, but still, okay, if just to take out some inference out of it. So the magnitude of error, the summation of error here, you see it is 12, and the magnitude of summation of error in this case, if you see, it is coming as minus 3.4. Okay, so you can say that this model is better as compared to the previous model. Okay, so this is a kind of approach. Okay, the kind of learning approach is there in case of supervised learning. Okay, so once again I'm summarizing this whole approach. So we have some sort of data. Okay, and based upon that data we have a model. That model is able to apply a logic on that data. So the theoretical logic is y, or speed, is equal to distance upon time. This is the theoretical logic, but we know that in real time this logic is not going to work. So when we are actually traveling, at that time, if we want to basically understand that what will be the actual speed, we will have to also consider road conditions and traffic and certain more parameters. So we have just added road condition and traffic, and we were actually this is something we were able to observe. Okay, we were able to observe that the speed was coming as 3.47 kilometer per hour, 4.66 kilometers per hour. Okay, but we were not able to get it, that why the speed is coming this, because actual speed should be 4.57 kilometers per hour. But we actually realized that there are other parameters. So the algorithm learns. Okay, so this algorithm is learning, and the algorithm learned, and then it learned that road conditions and traffic are also affecting, and it was able to come nearer to the actual output 4.57. But later on, the algorithm was able to evolve and added certain more parameters into it and was able to adjust the predicted output, and this time it was very near to the actual observed output. So 3.47 and 3.27. So 3.27 is nearer to this, and 3.0 and 4.07 is not nearer to, is farther than as compared to the new model. Okay, so this is a kind of approach of supervised learning. Okay, supervised learning again, which is being used in AI. I will tell you that also. Okay, in a complete project kind of thing. Okay, which maybe we will be dealing tomorrow. Now let me tell you the another approach, that is unsupervised approach, and then if time permits, the reinforcement. Otherwise, I have a complete use case for reinforcement to be discussed. So now I'm going towards the unsupervised approach here. Let me go there. And let me just have a quick confirmation in the chat box. Are we all good till this point? Yes. So are we all good till this point? Any questions, queries, inputs are most welcome. Feedback link. Okay. Yes. 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 Okay. Thank you. Okay. Anything specifically if you want as a use case or as an example to be included? Even I'm open for that. Like you may please put it in the chat, and I can include it in the like next day or next to next day. Okay, okay, fine. Yes, yes. So I think coordinators will share the video. Okay. So next approach, unsupervised approach. Understand, I have not taken any specific algorithm here. What I'm taking is, this is the fundamental approach. Okay, we can discuss on a lot of algorithms as well. Okay, which we will do. Few algorithms we will discuss. So I have taken the fundamental approach, like a person who is starting to build a supervised model. So he should have, or she should have, this understanding that how the what is the intent of that algorithm. The intent of that algorithm is to formulate a mapping between the x and y, and your x could be one or many, and your even your y could be more than one. Okay, so we are not getting into that part as of now. Okay, so your inputs can be more than one, and your outputs can also be more than one. Okay, so we are not getting into that as of now. Now I'm just taking another example where we just have x, we don't have y. Okay, we just have x. So we just have input. Now this x can be anything. Let's say this x is age. Okay, this x is age. So if the x is age, then in that case, let me again put it as a random value. So Excel is again very nice tool. So let me say that we have people starting from 12 to, let's say, 55. Okay, okay. Yes. So this is a list we have here. Okay. Okay. Let me just make it. How many are there? 17. Okay. Let me extend it to 20. 18, 19, 20. And similar way, 20. Okay. Fine. So here we have x, which is age. Let me write it as x is age. And based upon age, let's have some more thing. Let's have uh, mm, 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 mm. Yes. So what we can say? Yeah. Let me take activeness. Okay. So again, this is something not quantitative, but I'm taking it as quantitative. Okay. So activeness. So I'm just writing some formula, and then we will try to work upon it. No, no. Let me not take activeness. I'm sorry. Let me not take activeness. Let me delete this. Yeah. Let's work on only one parameter. Otherwise, it would have become supervised if I would take activeness here. So we just have age. Okay, so we have 12, 34, 16, 51. So we have got this. And now we need to identify, okay, we need to identify that um, how many types of people on the basis of age do we have. So we need to identify how many types of people on the basis of age do we have. So if we need to identify this, okay, then what should be the approach? So first thing, okay, we don't have y, we don't have there's no basically output here, we just have x value. So similar way here we have only x as x1, we can have x1 x2 x3 as well, okay, but we are only working on one just to make it simple to understand. So now approach, I'll tell you the approach. What should be the approach here? So here what we need to do is we need to work upon, first thing I can do is I can make this in order. So in order to use these values, because these values are, you can understand, randomly generated, so always these values will keep on changing. So I'm just pasting them, and here I'm just putting paste values only, okay, so now they will not change. Yeah, that's nice. So 20 people's data I have, and now I need to see that how can we how can we have their grouping. Okay, so grouping is the objective. So we call it as clusters also. So we want to formulate clusters. Now another question is how many, okay, how many clusters. So I will just try to demonstrate one simple technique to do that. So for how many clusters, I'll just select this much of data, and I'll just put a filter over here. Where is the filter? Data. Are we seeing filter here? Yeah, so here's the filter. So I have put a filter over here. Okay. And with the help of filter, what I will do, okay, I will just sort it. I have sorted it. Okay, you can see that I have sorted this. Okay, and this is nice. Now it is sorted. Now what I will try to do is, okay, how many clusters? I'll just try to identify, okay, yeah, let me draw a graph out of it, okay, because a graph is going to help me. So insert chart, okay, and here, yeah, line chart is okay, got it, line chart is okay. mm, I should aggregate, okay, and for aggregation I should do count, okay, and which column it has taken, C. Let me just okay, so just a second, count I cannot take, let me not aggregate then. I switch rows, 28 as header, 28 as header, no, column B as label, so B as label 1 2 3. No, we cannot take it as label, no, okay, so okay, fine, it is fine as of now. I should have, just a second, let me just uh, this is fine, this is one representation, as a representation it is fine, let me keep it here, and let me just create a graph for this much data, okay, so that will help us to analyze this. And here we can have add series, customize horizontal axis, okay, it's taking time, so I'm not very good with Excel, so let me just try once more. Yeah, anybody good with Excel can help me with grouping. SQL is good for this. insert format, edit. Okay, no worries. So I'll have to do it manually otherwise, or let me just do it like this. Um, one and yeah, one and one. Let me do it as two, and or I can do it here. Sort by color, condition, filter by condition, none, not empty. Okay, no worries. Let's discuss it manually then. Okay, so in this particular chart, okay, in this graph itself, if we see, let me bring it here. So we are able to see this graph. I just wanted to do a grouping, and there is a method called as elbow method, and with the help of which we can identify that how many like from where exactly we how many groups we can create. Okay, so there's an elbow method which is called as, so that I'm not able to do here in Excel. Okay, so yeah, with the help of elbow method or with the help of frequencies, we are able to know that how much groups should we create. Or there are other methods of creating hierarchies which tell us that like how many clusters can we create. But just looking at the data like this, I will just assume, okay, so that let's create 3 clusters out of it. Okay, so if we want to create 3 clusters out of it, okay, so groups and the number of groups will be 3. Then how basically we will be planning to create 3 clusters. Okay, how should we plan to create 3 clusters? So I'll take these values once again, and let me tell you in short here. I'm putting them here. Yes. So in order to create 3 clusters, I will have to choose 3 center points. Okay, and these 3 center points can be randomly taken initially. So I will take one center as, let's say, C1 as I will take 12, and I will take C2 as I will take let's say um, 13, and C3 I'll be taking as the maximum value. I think 57 is the maximum value we have. Okay, 52 is there, but you can take any value. It will not make any difference. The last output will is going to be same. Now what I am going to do is this is my first iteration. Okay, so first iteration I'm doing. So in this first iteration, whatever values we have, I will just try to identify the, let me identify the absolute ABS, yeah, absolute value for 12. 12 is the center minus this value. Okay, so absolute value for this. Similar way, I would try to identify for this and this. Okay, so here, okay, so this needs to be B, and no worries, Control Z. Yeah, this needs to be B, and this needs to be 13, and here in this case it needs to be 52, and this needs to be B. So if you see that the distance from the centroid or center point, okay, for the first value it is only 0, here it is 1, here it is 40. Okay, similar way we will do it for all the values we have. So here you can see. Okay, now what we will do, now we will create clusters out of this. Okay, now we will start creating clusters. How to create clusters? Wherever you find that the values are less, okay, least, you put that element into that cluster. So for example, now the C1 cluster would be, C1 cluster would be, here we can see the value is 12. Let me just write C2 and C3. Okay, so here you can see the value for 12 is the least here, the value for 12 is again least here, and the value for 13 is least in the second cluster, so 13 would come here, and the value for next 14 is least here, and the value for, so this way, okay, I'm creating a cluster this way. So value for next one 16 is again least from 13, so 16 would also come here, again 16 would come here, and this 24 is also going to come here itself, 24, and 26 is again going to come to, yeah, this place 26. Then again we have 26, so again it is going to come here, Okay, so you can see that the value which is nearest to the center, it is going to go to that particular centroid. Okay, so here also, which one is the least? 15 is the least, so 28 is going to come here, and 19 is the least, so 32 is also going to come to the this C2, and here 18 is the less, so this value 34 is going to come here, and then after this, yes, I believe now you can see all the values here would be going under this. Okay, so let me just take all these values. Okay, so these will be going under this. Okay, so now you can see that we have the clusters formed. Okay, now you need to plan for new centroids. How to plan for new centroids? You can simply plan for new centroids by doing a summation. So just do a summation here, sum, and here you find the sum and find an average. Okay, find an average. So this is sum, divide by COU, divide by the count, COUNT, count of, I can write this range, count of this range. Okay, so count of this. So here, yeah, so let me just see what is the count of this. It's 20, count is 20. Sorry, no, I'm sorry, this is wrong. Count should be of, yeah, so it should not be this count. Yes, so here the count should be of this. Yeah, count of this. Okay, so here you can see average is 12. Yeah, so similar way, this and this. So yeah, so here count of I, it is the ith column. Yes, it is the ith column. Fine. So we have got the new centroids. Okay, these are the new centroids we have got. Okay, and now for these new centroids, you need to follow this again. Okay, so if you follow this again for the new centroids, let me just take these centroids and take them here. Okay, these are the new centroids, and let me just put the values only. These are new centroids. Okay, and if you take this back again and try to do the same thing here. Okay, so now if you try to identify, you will find some differences in the C1, C2, C3 now. Okay, so once you are able to find no difference in the items of the cluster, okay, so you have to run it for those times. So this is first iteration, this is second iteration. Okay, so you have to run it multiple times, okay, until and unless you get the same values in the cluster. Second iteration. Okay, so here also the same formula. Okay, is equal to this 12 minus this, and we need absolute value, so I'll just write ABS, absolute value. Okay, so again, okay, and similar way this ABS. Okay, let me quickly do it. So this minus this, and done. And similar way here also ABS, absolute, and this minus this. Okay, yes, so once again we have got the values. Again you will find C1, C2, C3. Okay, and we will iterate. So we are getting a new set of C1, C2, C3 over here. Now which one is the nearest one, that we need to identify. Okay, so the nearest one, 12, again goes to 12 only. Okay, then here I think the formula is changed. Okay, so we'll have to work on the formula. Fine, so again we have to repeat this. So till the point we don't get the C1, C2, C3 clusters same, we have to keep on repeating this. Okay, so this may go to 3, 4, 5, 6, 7. If the data is large, maybe few hundreds of iterations, and then the final cluster is formed. Okay, so two conditions: either your centroid values are repeating, or the values inside the centroids clusters are repeating. Okay, so till that point you have to wait. Then you will get the actual clusters. After that, you will get the actual clusters. So I'm not solving it completely. I hope you got the sense of it. This is this algorithm. This is an algorithm which is called as k-means algorithm. Okay, so k-means algorithm. So this approach is applied in case of, this is one example of approach applied in case of unsupervised learning, where we are working on distances, or I have mentioned here that we work on similarity or differences. Okay, or differences. This is another approach. Okay, so your model can have a supervised approach, your model can have unsupervised approach, or your model can have a reinforcement approach. I'll just give an example of reinforcement, and then we will conclude. So let me just demonstrate it. We will discuss on it later. Okay, so I think I have it here in the notebook. So yes, so this example, so we will look into it tomorrow, okay, in detail, but let me just demonstrate it. Okay, so this is a scenario that I think I have a document also. No worries. You can think from, you can understand from here only. So here you can see that we have yes. So R, G, Y, B. So four positions we have here, and apart from those four positions, uh, we have a taxi over here, and this is basically this yellow color. You can see that is the representation of taxi. Okay, that is a representation of taxi. Now, in this case, what is just a second, yeah. So in this case, the scenario is that it is a parking space, a parking lot, and inside the parking lot, we have a taxi, and and the taxi needs to move from one place to another. So in order to make it simple, what we have done, we have created this environment which is easy to understand. Yes, and this particular position, okay, where R is written, that position is basically somebody is standing there, okay, and that person needs to be picked up, and that person needs to be taken to this Y location, okay. So a person is standing at one place, and that person has to be taken, and that person has to be dropped upon the Y location. Now understand how the taxi is going to identify. Taxi has no clue that where no clue that how to reach, let's say R, or how to reach Y, or how to reach G, or how to reach B. Taxi has no clue about it, but taxi just has got this much of this much of uh, I should not say knowledge, but taxi has got some action sets, that taxi can move towards front, taxi can move towards back, taxi can move towards right, taxi can move towards left. This is a six how many six kind of four kind of actions taxi is having, okay. And after that, two more actions, because it has to pick somebody and it has to drop somebody. So pick up and drop, these are two other operations. Now understand, taxi would be randomly moving, okay, randomly moving, because it has no previous data. So in this case, taxi is going to randomly move. Let's say these lines, they represent barricades, okay, these lines, they represent barricades. So if the taxi is going to move from this particular location, if it is going to move towards right, so it is going to hit the barricade. So if it is hitting the barricade, then there will be a damage. So in the program, we will be calling the damage as a penalty, okay, penalty to the taxi. So if there is a damage, that is a penalty to the taxi, and if there is a penalty, then a negative reward will be given. And whenever taxi is moving towards the pickup point, then we will reward something, okay, we will reward maybe some 10 points or something, we'll reward. And whenever taxi is picking the person up and dropping it into the right location, then there will be the highest rewards. So what this taxi is going to do, this is an agent, it is going to maintain two matrix, okay. One, we can have multiple matrix, I'm just giving you an example. So one matrix will store its movements, okay, it moved front, then it moved towards the right, And another matrix will be storing whenever it is making a move, whether it is getting some reward or whether it is getting some penalty. So this will be recorded in another matrix. So we'll have two matrix here. Okay, one is of the movement, another is basically whether it is getting rewarded or it is getting penalized over there, though that matrix. So let's say it tried to attempt something, and it tried for, let's say, 10,000 times it moved, and in 10,000 times it was able to successfully pick the person and drop the person. Okay, in 10,000 times. Similar way, another time it was looking back into that those matrices, that how I was moving and how I was getting rewarded or I was getting penalty. So it will try to keep avoiding the penalty and try to always get rewarded, and then it will see that only in 500 moves I was able to work. Again it will look into that and it will try to make little changes into the steps. So I have given you high level idea that how this will work. Let us just execute it and let me tell you. Okay, we'll discuss this in detail like in tomorrow's discussion. So here, this is reinforcement approach, and this approach is called as Q learning approach. Okay, so I have already, let me just clear out everything. So clear the output and yes. Okay, so let me import the libraries and let me render the environment. Okay, yes. So here taxi row, taxi column, passenger index, and okay, yeah. So we are setting up. Okay, yes. So let's set it up. Yes. So this is also a matrix. Okay. So taxi row is third. So 0, 1, 2, 3. So we'll discuss in detail. Okay, yes, tomorrow that part. And taxi column is 1. So this is the taxi position, and passenger index is 2, 0. Okay, so 2, 0 means second row. No, it index destination index. Okay, just it is index. So uh, yeah. So I'll just tell you about the colors. Okay. So here, yes, so as I told, there'll be a reward table and certain actions would be there, south, north actions. And let me just tell you on the iterations part. Okay, this is training part. Yeah, fine. And after Q learning. Okay, yeah. So here, let it get executed first. So at one place, what we did, we just let the taxi randomly, okay, take the steps, and we have tried to calculate the time step. Okay, yes, and this is the that part. Okay, without reinforcement learning. Yes. So here it took around 260 time steps and penalties 77. 77 penalties incurred and 260 time steps it has taken. Okay, then after that, yeah, I'll explain these things to you later. Let me just, yeah, training. So after training, yes, so now it is getting trained. Okay, so once it is getting trained, as I told you, it will create two matrix, and one will have the movements, another will have the records of penalties it is getting or the rewards it is getting. And after that, okay, so here we have mentioned that it should run for ones, tens, 100,000, 10,000 lakhs. Okay, so 1 lakh times it will be running. So 65 already done. So for a few more seconds, we'll have to wait. So then we will try to identify this, that how much time steps does it take? Okay, at that particular time. Let it get, yeah, it is almost getting completed now. Okay, here it is finished. And now let us get here. So results after 100 episodes. So average time steps per episode, it took just 13.21. Okay, so after learning, if you say penalties, so it did not hit any of the barricades. It successfully was able to pick that person up and drop it off there. Okay, so just to keep it like a motivation, that if we are using this at that particular time, what is happening? At that particular time, we are able to make a very big impact on the performance of our agent. Okay, so this we will discuss tomorrow. And yes, tomorrow I'll be mapping up all the terminologies, like we have as per the plan, so that with terminologies also we are all clear that what exactly is happening, because these things are overlapping with machine learning as well. So I will try to clear you on the terminologies of AI and what terminologies are used in machine learning as well. So with that approach, I'll be moving ahead. So that's it for the day. If any questions or something is there, queries are there, I am okay to discuss. And if everything is good, it is fine. Okay, so shall I, if I ask coordinator, shall I create a Google Classroom and share the link of it? Is it fine?
That will be fine. That will be fine.
Okay, I'll share it on email. Then you can broadcast it. I'll just create and share
Sure,
it on
sure.
email. Yeah, yeah. So let me just stop the sharing part. Did I stop? No.
Yeah.
Stop sharing. Okay.
Participant, if you have any queries or the questions related to the session, you can ask. Mr. Kushal is with us. Yeah, I hope all the concepts are clear from participant side. So, Mr. Kushal, I think we'll conclude today's session, right?
Okay. Okay. Sure. Sure. Yeah.
Yeah.
Yeah. Car driving. I'll explain. Yeah. That I have kept for
One
tomorrow.
second.
Yes, I'll do
Yeah.
that. Okay.
Sure. So, dear all the participants, thank you for attending this session. Your attendance and the presence, you can see that the success of our workshop definitely will continue the same for the next coming days. Thank you once again for your patience and attending the session so eagerly. Thanks a lot, and thank you, Kushal, for giving such a informative information to all the participants. I hope we'll see you tomorrow, and we'll continue with the next session. Thank you.
Sure. Sure. Thank you.
Thank you. Yeah.